Flip over your handout that has the 3 problems on it, please. You're going to be turning this in. We're going to work through all the steps of how we solve them to give you guys a little more practice, a little more instruction, okay? I'll put the link after I post it, but this is the link for the lesson, okay? So if you missed the lecture yesterday, go in and watch this so you're ready for the test on Thursday. Does everyone have the printout that was in the back? Go ahead and flip it over now. Okay, as we do these, I want you guys to write the steps out. So when we're looking at this one, the first thing we want to do is take a look and say, what's the fastest way to solve this? Well, the fastest way to solve this one is we have 2 positive y's, right? So we're going to stack them on top of each other. Our first step, x plus 2y equals 5. Go ahead and do that. 3x plus 2y equals 17. Write it down, please. Okay, it doesn't matter which one that we multiply, we're going to get the same answer regardless. So I'm going to multiply this top one. So I'm going to put parentheses on the outside and I'm going to put minus 1. Okay? Now I'm going to make sure you write this down, please. Okay, a mistake that I saw yesterday is this. Not multiplying everything in here, only multiplying the one we're trying to get rid of. You want to multiply everything in here, all the terms, okay? So let's go ahead and do that. Negative 1 times x, negative x. This is going to turn this to negative 2y. And it's also going to turn this 5 to negative 5. Does everyone understand? Remember, thumbs up or thumbs down, okay? If you don't, then I'll go through it again. Okay, so I multiplied 1 by everything in here, right? Now I change this. Now I'm going to take this other one, I'm going to write it underneath it, stack it on top of it so I can solve it. Now, I'm going to show you a step that I think is beneficial. When you're dealing with this 2y and you know you have it canceled, just draw a line through it. I think it's easier. You don't get confused with the problem. Okay, so now we're going to go ahead and do this. We have 3x minus x, which is what?
2x.
2x. And then 17 minus 5? 12. So we're going to divide by 2. We're going to divide by 2. X equals 6. Is there any questions on the first part?
It's not negative 12?
Look here. Positive 17, negative 5. Larger one retains the symbol. Good question to know. Okay. Now that we have that, we want to go to our next step. So we stack them on top of each other, we eliminate it, solve, now we want to go and do substitution. We want to take this in the very one that we changed, okay? So we're going to write x plus 2y equals 5, draw a line underneath it, okay? Go ahead and do that. Okay, from here, we're going to enter this 6 inside here, okay? So it's going to be 6 plus 2y equals 5. We substituted the 6 in. Okay? Now we're going to solve. We need a 2y by itself, so Naomi says minus 6 from both sides. She's going to cancel this out, and then she's going to have 2y equals negative 1. Okay, typically this is where there's some confusion. We're going to divide by 2, because that's what Naomi did, and then she's going to divide this by 2. Now, Naomi looked at that and said, oh, I know what to do with that. That's a negative and positive. So how I simplify that is y equals negative 1/2. Good job, Naomi. So now, very last thing is, we're just going to state the ordered pair. So our ordered pair is 6, negative 1/2. Let me see thumbs up or down. Okay, sideways. Okay, let's go through it again. I like that one. Okay, we take our 2 linear equations, okay? We stack them on top of each other, then we take a step back and we take a look. We say, okay, I got 2 positive 2y's. So if I take one of those equations and multiply it by -1, I can get a negative 2y and a positive 2y. Does everyone understand that? Thumbs up, down? Because we're trying to eliminate something at the end of the day, right? Okay, so from here, we go ahead and multiply everything that's in here, every term. We have a term of x, we have a term of 2y, and we have a term of 5. So we take the -1 times x, negative x. If you want to put the 1 in there, you can, if it helps you. -1 times positive 2y, negative 2y, and -1 times 5, negative 5. Now notice, these are all positive in here, so all this negative did was change them all to negatives. Now if there's a negative in here, it would have turned it positive, right? So after we do that, we take the other equation and stack it on top of each other, okay? And then from here, we're adding and subtracting. 3 minus x, 2x. 17, you have $17, so you pay someone 5, you have 12 left over, and then divide by 2, x equals 6. Are we good with this part? Thumbs up? Okay. After we get the 6, we're going to take the same equation that we modified, okay? We're going to write that equation, we're going to draw a line underneath it. Now the reason why we do this, it helps us see, okay, I have not modified this yet. I need to take this and I need to substitute the x inside, okay? So I take this x, I change it to 6, and bring down the rest of the problem. Are we good? Okay, from here, go ahead and solve. We want the 2y by itself, so we're going to subtract 6 from both sides. This negative 6 plus 5. Now we learn from this situation, it's like, okay, I owe someone $6 and I paid them 5, I still owe them $1. Bring down the 2y, divide both sides by 2. Well, when we can't divide it, when it won't go into this number, then we leave it as a fraction, okay? Simplify if you can, like if this were 2/6, then we can reduce it to 1/3, right? So, ultimately, when we're all said and done, we can't have a negative numerator, so we move it to the outside because it's a negative divided by a positive, and it becomes negative 1/2. So we have our ordered pair. We have our x, and we have our y. Okay? Thumbs up. Let me see. Down. Sideways. Okay, good. You staying with me?
Yeah.
Okay, are you good? Lies. Okay, let's work on this one. Is there any clear-cut way to solve this one? Go. What are you thinking?
Try to get the x the same.
Oh, you know what? That's supposed to be 7y. Sorry. Yeah, x's or y's, it doesn't matter. You'll notice in most of your problems, you're dealing with the y's first, typically, and then solving for x after. So all this means is, we're going to take this equation, we're going to follow our first step, and we're going to stack it on top of each other. So 5x plus 2y equals -1, and then 3x plus 7y equals 11, okay? Now, if I'm trying to approach this problem, I'm going to try to take care of the y's, okay? So, how I'm going to start this problem, 7 times 2 is 14, right? So I'm going to put this in parentheses outside of here, I'm going to take this one, parentheses outside here. I'm going to make this a 7 and make this a 2. All I did was flip these over, okay? Because there's no real, I got to multiply both these any which way I look at it. There's no easy scenario of how to actually solve these. So one of these has to be a negative. So I put a negative here, and one of these has to be positive. Okay? Let's take a step back. This was positive, positive. We multiplied by -1, and we got it to eliminate, right? We're trying to get things to eliminate. So coming back over here, we don't have a clear-cut way to solve this. So we have to address both equations to get rid of it. Yes?
How did you get -7?
Because 7 times 2 is 14, right? So I'm going to look at these two, I'm going to multiply them. Unless I have a common factor, which I don't have a common factor because 7 is a prime number. Okay? So I just multiply them. So if this one's 2, this one has to be 7. If this one's 7, this one has to be 2. I'm just multiplying by each other. Now, Naomi, one of them has to be a negative, and one of them has to be a positive. Okay? Well, both these problems are positive, so we don't have a choice. One of these has to be negative, one has to be the positive. Okay? From here, now we do distributive property. We take -7 times 5, which is -35x, and then we take 7 times 2, minus 14y, and then -7 times 1, positive 7. Any questions on that? Thumbs up? Okay, next one, we're going to do the same thing. 2 times 3 is 6, so 6x. 2 times 7, 14. 14y. 2 times 11, 22. Any questions? And I didn't have to write this like this, right? I didn't have to write it as plus 7, because normally you wouldn't write it that way. So draw a line underneath it, and then we're going to go ahead and solve. So, now this is negative 35 plus 6, so it's going to be minus what?
29.
29x. Good. This cancels out. We're not worried about this. Then we're going to come over to here. 7 and 2. Look what just happened. 29, right? So now we're going to divide by negative 29. We're going to divide by negative 29. And what is my x?
Negative 1.
Negative 1. Very good. Now I want you to notice something. We modified both equations, right? Correct? We modified both of them, so it doesn't matter. What I normally do is just take the top one. So we're going to take 5x plus 2y equals negative 1. We're going to draw a line underneath it. Then we're going to plug in our negative 1 for our x. So this is going to be 5. What Naomi likes to do, because she's well versed in making sure she goes through the steps, that means multiplication. So she's going to put that negative 1 inside parentheses. And then she's going to bring down the rest of the problem. Right, Naomi? And then when Naomi looks at this, she's going to do multiplication first, because she's going to follow PEMDAS. So 5 times negative 1, negative 5, and then she's going to bring down the rest of the problem. She's going to do the inverse operation. She's going to add 5 to both sides. She's going to cancel this out, and she's going to get 2y equals 4. Then she's going to divide. She's going to divide by 2. She's going to divide by 2. Y equals 2. So then she's going to state her ordered pair, negative 1 and 2. We're done with that one, aren't we? I really like the next one.
Well,
I do. I'm going to pick on Daisy now. So Daisy's looking at this problem, and she's like, wow. I got a 3 and an x, and I have a 3 and a 9. Guess what, though? Daisy takes a look at that and says, you know what? 3 goes into 9. And if I can only change one linear function, I'm going to do that. Right, Daisy? So then what Daisy does, she follows her first step, and she writes 9x minus 3y equals 3. And then she writes 3x plus 8y equals negative 17, right? Then she sees this 9, she sees that it's positive, she puts this in parentheses and she multiplies it by negative 3. Good job, Daisy. So from there, she's going to go ahead and multiply this out. Now, a good step, this is what I do. I take this one, since I'm not modifying, and I write it again. 9x minus 3y equals 3. Let me show you why I do that. Then I can just multiply this out and put it at the bottom. So 3 times 3 is negative 9x. And then 3 times 8, negative 24y. And then 17 times 3 is 51. Positive. So we draw a line here. Now Daisy got her x's to eliminate, right?
awesome.
Very good. We should do this one too, right? Just for good reference. Because then we don't get it confused. We know exactly where we went. Okay, from here, now we got to deal with the y's, right? We're both negative, so we're going to add them, right?
Yeah.
What is 4 plus 3?
26.
It's 27.
Oh, 27.
27 equals, and 51 and 4? Right? Okay. We divide by negative 27. We divide by negative 27. And how many times does 27 go into 54?
Like 4 times.
Check. I'm thinking 2. Even? So we have no fraction? Okay, so we have our y, don't we? Now, look at this. We modified this one, right? So Daisy says, I'm going to use that same one to go and put this information in. So she writes it. She writes 3x plus 8y equals negative 17. She draws a line underneath it. And then she's going to go enter her negative 2 inside her y, right? So she rewrites the problem. 3x plus 8 in parentheses negative 2 equals negative 17. then from here she follows order of operations. So 8 times 2, negative 16, equals, I'm sorry, negative 16 equals negative 17, and she brings down the 3x. Okay, Daisy, drive me home. What else do I need to do now? Very good. Add the 16 to both sides. Naomi likes this. Makes you feel more comfortable. What happens here? Negative 17, positive 16. Okay, this is the one. This is what Naomi likes these because she thinks they're easy. We divide by 3. We divide by 3. What's our answer? Excellent. So we have our ordered pair, right? Negative 1/3 is our x, and our y, and our y is negative 2. We're done with these, right? Okay, you notice all the 4 steps? You notice how they flow? Okay, there you go. So, you want to turn this in with all the steps written out. It's part of your assignment today, and you want to get your do now done today, okay?
So we don't do a do now.
You do. Your do now is on the other side of the sheet. Just do it on a separate sheet of paper when you go to turn it in. Also, I will put the link up for this today if you want to look at it getting ready before the test. This one is on the lecture yesterday, Lindsay.
Mm-hmm.
So you might want to write this down and go watch this, and you can go through the lecture again. Okay, it takes about 10 to 12 minutes. Okay, are we good? All right. Yes. I'll be in there a second.